Hello students, welcome to this session of Physics for Class 11. In today's session, we will answer multiple choice questions that are likely to be asked in your examinations. We are answering chapter-wise questions and today's topic is units and measurements. You also should note that important steps in solving multiple choice questions are: first step, decode the concept. Second step, identify the formula. And third one is focus on the requirement. We have taken questions from all the chapters, that is 2.1 to 2.10, as well as some questions from chapter 1. Please go through it meticulously and note down all the important points. I welcome you once again. Multiple choice questions. Question number 1. The units of fundamental physical quantities are called. You have four options. Option A, supplementary units. Option B, base units. Option C, derived units. And option D is all of these. So you have to identify the units of fundamental physical quantities. So the correct answer is, you have to remember that fundamental physical quantities are also called base unit. So choice B is the correct answer. So option B is the correct answer. You mark it. Question number 2. Physical quantities other than fundamental quantities that are expressed as combination of base units are called. So you have four options. Option A, derived units. Option B, base units. Option C, system of units. And option D, MKS system. So you have to identify the physical quantities other than fundamental quantities that are expressed as combination of base units. So the correct answer is A, option A, that is derived units. So other than fundamental quantities are derived units. Next question. Which of the following quantities has the same unit in all the three systems of the units? So the unit is same in all the three systems of units. That is, you have MKS system, FES system and SI system, which is common for all the three. Whether it is option A, mass, option B, length, option C, time, and option D, luminous intensity. So the answer is the unit of time in seconds is common for all the three systems. So you mark the correct answer as C. Next question. The system of units which is at present internationally accepted for measurement is option A, MKS system, option B, FPS system, option C, SI system, option D, none of the above. So you have to identify the system of units which is at present internationally accepted. The system of unit which is at present internationally accepted for measurement is Système Internationale d'Units. That is French word for international system of units. So you mark C as the correct answer. Next question is question number 5. Which one of the following is not a derived unit? Is not a derived unit. So watt, option A is watt, option B is Newton, option C is joule, and option D is kilogram. So the correct answer is kilogram is a base unit. So all others are derived unit. Watt is a derived unit, Newton is a derived unit, and joules is a derived unit. So only kilogram is a basic unit. Option D is the correct answer. You please mark it. Next question. Question number 6. Pick the years in which SI system of unit was developed and recommended and revised. So there are four options. Option A, 1951 and 1961. Option B, 1971 and 2018. Option C is 1971 and 1981. And option D is 2001 and 2011. You have to remember the year in which SI system was developed and recommended and revised. So SI system was developed and recommended by General Conference on Weights and Measure in the year 1971, and recently, that is in the year 2018, it was revised. So therefore option B is the correct answer. Next question. A body travels uniformly at a distance of 13.8 plus minus 0.2 meters in a time 4 plus or minus 0.3 seconds. Its velocity with error limit is, so you have to find the velocity among the four options. The four options are option A 3.5 plus minus 0.3 meters per second, option B 3.5 plus minus 0.6 meters per second, option C 6.1 plus or minus 0.6 meters per second, and option D 6.1 plus or minus 0.3 meters per second. So you have to do some calculation. Let us do it in a inset table, inset square. Inside box, velocity is equal to, we know, distance over time, that is S over T, and it is given distance as 13.8 meters and time is 4 seconds. So 13.8 divided by 4 is equal to, you use the calculator and find 3.45. The ratio is 3.45. Velocity is 3.45 meters per second. So writing it to the single digit, rounding off to the single digit after decimal point, that is 3.5 meters per second. Now to find the error, we know that error is given by delta V by V is equal to delta S by S plus delta T by T, where delta V is the error, given error, and V is the velocity, error in velocity to velocity. So delta S is the incremental error in distance and S is the distance. So delta T is the incremental time over T, that is error. Error in time T is given by delta T by T. Error in S is given by delta S by S, and error in velocity is delta V by V. Therefore, substituting the values, delta S is given as 0.2. That is, you see, 13.8 plus or minus 0.2 is the error. Therefore, delta S is 0.2 divided by 13.8, and plus delta T is 0.3 divided by 4.0. So simplifying and taking the LCM, we calculate and get it as the answer as 0.0895. Delta V by V is equal to 0.0895, or delta V is equal to V into 0.0895. That is equal to 3.5 into 0.0895, and the answer is delta V is equal to 0.3087. That is, error in velocity is 0.3087. Rounding off to the single digit after decimal point, it is 0.3. Hence, velocity is 3.5. We have found it here, and error is 0.3. That is meters per second. So, answer is available in option A. Mark it as option A. Next question. The value of universal gravitational constant G equals 6.67 into 10 to the power of minus 11 Newton meter square per kg square. The value of G in grams per gram centimeter cube per second square is, we have to identify the answer. Four options are given. All are starting with 6.67 into 10 to the power of minus 8, and option B is 6.67 into 10 to the power of minus 7. Option C is 6.67 into 10 to the power of minus 9, and option D is 6.67 into 10 to the power of 10 minus 10. So we will calculate it. G is given as 6.67 into 10 to the power of minus 11 Newton meters per kg square. This is given. Now we have to find it, convert it Newton into kg meters per second square and meters into centimeters, and kg we have to retain as it is. Therefore, 1 kg is 1000 grams and 1 meters is 100 centimeter, and again meter square is 100 centimeters and kg square. So conversion, we get the answer as 6.67 into 10 to the power of minus 8 per gram centimeter cube per second square. So you mark it. So the option A is the correct answer. You mark it, please. Next question. Next question, that is question number 9. The SI unit of pressure gradient is, four options are given. Option A, newtons per meter square. Option B, newtons meter. Option C, newtons per meter. Option D, newtons per meter cube. So let us do some calculations. Pressure gradient is given by pressure over distance, but SI unit of pressure is newtons per meter square and distance is m. Therefore, SI unit of pressure gradient is n into m to the power of minus 2 divided by m. So when this m goes to numerator, it becomes m to the power of minus 3. Therefore, SI unit of pressure gradient is n, capital N, m to the power of minus 3. It is given in option D. Let us mark it. Next question. Question number 10. The relative density of lead is 11.3. Its density in SI unit is, four options are given. Option A, 1.13 into 10 cube. Option B, 1.13 into 10 square. Option C, 1.13 into 10 to the power of 4. And option D is 11.3. Please note, relative density is given as 11.3 and we have to find the density in SI unit. So let us do some calculations. So we know that relative density is equal to density of substance over density of water. But we also know that density of water is 1 into 10 to the power of 3 kgs per meter cube. Therefore, density of lead is given by relative density into density of water, that is cross multiplying. So, relative density of lead is given as 11.3. You put this value 11.3 into density of water. We know that 1 into 10 to the power of 3 kgs per meter cube. That becomes, rearranging the decimal place, we get 1.13 into 10 to the power of 4 kg per meter cube. This answer is given as option C here in the table. Therefore, you mark option C as the correct answer. Next question. If the value of atmospheric pressure is 10 to the power of 6 dyne per centimeter square, its value in SI unit is, so the atmospheric pressure is given in dynes per centimeter square, and we have to convert it into SI unit. So 4 options are given. Let us find which option is correct. Let us do some analysis. We know that 1 dyne is equal to 1 into 10 to the power of 5 newtons. So to convert dynes into newtons, we have to multiply it by 10 to the power of minus 5. Therefore, pressure is given as, atmospheric pressure in dynes is given as 10 to the power of 6 dynes per centimeter square. So we have to multiply 10 to the power of 6 into 10 to the power of minus 5 to convert it into newtons. Similarly, we have to convert centimeter square per square is equal to 1 over centimeter at centimeter. This we have to convert into meter. We know that 100 centimeters constitute 1 meter, or 1 centimeter is equal to 0.01 meters into 0.01 meters. That becomes 10 to the power of 5 newtons per meter square. This option is given as C. Here you please mark it. C is the correct answer. Next question. Question number 12. One bar is equal to. 4 options are given. Let us find out by analyzing. A bar is the cross-sectional area of uranium nucleus. So it has to be very small, and its power has to be of the order of minus. We have to remember that 1 bar is equal to 10 to the power of minus 28 meters square. It is given in the tables of chapter 2 as well as uh, in table of chapter number 1. So you mark the correct answer as C. C is the correct answer. Next question. Question number 13. Fathom is the unit to measure the. 4 options are there. Option A, speed of ship. Option B, depth of sea. Option C, distance of the ship. Option D, speed of cyclone. You have to choose the correct answer and mark it. So let us analyze. Fathom is a unit of length, that is equal to 6 feet. It is used to measure the depth of sea, and this answer is given in choice B. So you mark it. Next question. Question number 14. Which one of the instrument is not used for measurement of the length? Option A, atomic clock. Option B, vernier calipers. Option C, screw gauge. Option D, spherometer. We know that atomic clock is used to measure the time. So you remember. So the question is, the which one of the instrument is not used for measurement of, not used. So atomic clock is not used for measurement of length. So you mark it. Choice A is the correct answer. Next question. Question number 15. Light year is option A, light emitted by sun in 1 year. Option B, time taken by light to travel from sun to earth. C, distance traveled by light in free space in 1 year. Option D, time taken by earth to go around the sun. So you have to choose the correct answer. You have to remember that light year is the distance, is a measure of distance traveled by light in free space in 1 year. That is normally from sun to earth. Therefore, option C is the correct answer. Question number 16. Which method is used to measure the distance of a planet or a star from the earth? There are 4 options. Option A, echo method. Option B, parallax method. Option C, triangulation method. And option D, all the 3 above. So the correct option is, you have to remember that parallax method is used. So mark it as B. B is the correct answer. Next question. Question number 17. One unified atomic mass unit, that is 1U, is equal to, four options are given. Option A, 1.66 into 10 to the power of minus 25 kgs. Option B, 1.66 into 10 to the power of minus 27 kg. Option C, 1.66 into 10 to the power of minus 29 kg. Option D, 1.66 into 10 to the power of minus 31 kg. You have to remember the correct value of atomic mass unit, unified atomic unit. So it is 1.66 into 10 to the power of minus 27 kg. You please mark option B as the correct answer. Next question. Question number 18. 10 to the power of minus 3 gram is called. There are four options are given, A, B, C and D. You have to remember it. So 10 to the power of minus 3 is milli. So it is milligram. You have to remember and mark B as the correct answer. Next question. Question number 19. If the value of force is 100 newtons and value of acceleration is 0.001 meters per second square, what is the value of mass in this system? So that is newtons, you have to convert into, that is kg, mass and seconds. So let us convert it. So option given is kg. So that means 100 newtons should be converted into kg. Option A is 10 to the power of 3 kgs. Option B 10 to the power of 4 kg. Option C is 10 to the power of 5 kg and option D is 10 to the power of 6 kg. Let us do some calculations. We know that force is equal to m into A, where F is force, m is mass and A is acceleration, or mass is equal to F by A. So mass is equals 100 newtons. F is given as 100 newtons and acceleration is 0.001 meters per second square. So newtons, we know it is newtons is 1 newton is equal to kg meters per second square. You put the value as kg meters per second square divided by 0.001 meters per second square. Meters per second square in numerator and denominator gets cancelled. Therefore, what is remaining is 100. When it 10 to the power of 0.001 is 10 to the power of minus 3. When it goes up, the answer is 10 to the power of 5 kg. The correct answer is given, choice is C. So you please mark it. Next question. Question number 20. Light from the sun reaches Earth approximately in, options are option A 5 seconds, option B 50 seconds, option C 500 seconds and option D 0.5 seconds. So we have to do some small calculation. Please see the insert box. So time taken by light to reach Earth from Sun is, you have to remember, 8 minutes and 20 seconds. That is equal to 8 minutes, we have to convert into seconds. Therefore, 8 into 60, because 1 minute is equal to 60 seconds. So 8 into 60 plus 20, that is 480 plus 20, that is equal to 500. 500 second is the correct answer and this answer is given in option C. You please mark it. Next question. Question number 21. Which of the following is not the unit of distance? Option A, light year. We know that it is a distance. Astronomical unit. Option C is parsecond. It is a unit of distance. Astronomical unit is also a unit of distance. Option D is millisecond. Millisecond is 10 to the power of minus 3 seconds. So it is the time. It is unit of time. Option D is unit of time. So option D should be correct answer, which is not a unit of distance. Therefore, option D, you please mark it as the correct answer. Next question. The dimensional formula for omega in relation A sin omega t is, we have to know the dimensions of, he is asking the dimensions of omega, which is appearing in the equation y is equal to a into sin omega t is, four options are given: m to the power of 0, l to the power of 0 and t to the power of 1. And option B is m to the power of 0, l to the power of 0, t to the power of minus 1. And option C is m, l to the power of 0, t to the power of 0. And option D is m to the power of 0, l to the power of minus 1 and t to the power of minus 1. So you have to analyze it. Omega is radians per second. Omega is the angular frequency and it is given in radians per second. That is equal to 1 over t. Therefore, there should be t to the power of minus 1. T to the power of minus 1 is appearing in B as well as option C. So L to the power of 0. So therefore, there is no item of L in this omega. So option B must be correct answer because M is 0, L is 0 and T is minus 1. So you mark answer B as the correct answer. Next question. The dimensional formula for Curie is option A, M to the power of 0, L to the power of minus 1. So let us find out the dimensions of Curie. Curie equals unit of radioactivity, that is equal to dN by dt, unit of radioactivity. Therefore, it is t to the power of minus 1 or m to the power of 0, l to the power of 0, t to the power of minus 1. So, this option is given in t to the power of minus 1 is appearing in option A as well as option C, but it should be L to the power of 0 also. A has L, but C has got option L to the power of 0. M to the power of 0, L to the power of 0 and T to the power of minus 1. So option C should be the correct answer. You please mark it. Next question. Which of the following pairs of physical quantities does not have the same dimensional formula? So tension is equal to force mlt to the power of minus 2. Force is mlt to the m into a, mlt to the power of minus 2. Surface tension is equal to force per length, that is equal to m into t to the power of minus 1. Therefore, the correct answer is, so does not have the same dimensional formula. So correct answer, that is does not have, is option C. So the tension and surface tension have different formulae. Next question. Question number 25. If momentum rho area A, if momentum P small p, area capital A and time t are taken as fundamental quantities, then energy has the dimensional formula. We have to find the dimensional formula for energy, taking momentum, area and t as fundamental quantities. So four options are given. A is equal to P into a to the power of half into t to the power of minus 1. Close the bracket. B, P a to the power of minus half t to the power of 1. C, option C, P square a t. And option D, P a to the power of minus 1 t. We have to make some small analysis. Let us do it. We know energy. The question asked is about energy. Energy is equal to force into length. So force itself is change in momentum over time, and length per unit area into length is multiplied by square root of A. Therefore, change in momentum is P, and a to the power of half and t to the power of minus 1. Therefore, the option given here is P a to the power of half t to the power of minus 1. That is the correct answer. Let us mark it. Option A is the correct answer. Next question. Question number 26. Out of 4 and 4.00, which is more accurate? So 4 options are given. 4.0, option B 4.00, option C both are equally accurate, option D nothing can be said. So let us analyze. Remember that this option B has 3 significant digits 4.00. So option B will be more accurate. You have to remember. Question number 27. Speed v of sound in gas is given by v is equal to k into p to the power of x rho to the power of y, where k is a dimensionless constant, p is the pressure, and rho is the density. Then option A, x is equal to half. We have to find the value of x and y. Then x is equal to half, y is equal to half is the option A. Option B is x is equal to minus half, y is equal to minus half. Option C is x is equal to half and y is equal to minus half. Option D is x is equal to minus half, y is equal to half. So let us make some small calculations. It is given v is equal to speed v of the sound is given equal to k into p to the power of x and rho to the power of y. P is the pressure, rho is the density, and k is the dimensionless constant, and v is the speed. So we have to put the dimensional formula for each term. V is equal to velocity. We know that m to the power of 0, L t to the power of minus 1 on the left hand side. On the right hand side, k is dimensionless. So we have to put for pressure. Pressure is mass per unit length per time square. Therefore, P is m L to the power of minus 1 t to the power of minus 2. You have to remember for pressure. The dimensions of pressure is m L to the power of minus 1 t to the power of minus 2. And density is mass over unit volume. That is equal to m divided by L to the power of minus 3 and whole to the power of y. So P is to the power of x here and rho to the power of y. Now we have to equate the powers of each term. M is 0. So right hand side we have m is equal to m plus m 2. Therefore m is equal to mx, that is x plus y is equal to 0. And equating the powers of length, L1 is equal, power of L on the left hand side is 1. On the right hand side, it is minus x minus 3y. Therefore, and equating the powers of t, that is time, minus 1 is equal to, on the right hand side, we have minus 2 to the power of x. So minus 1 is equal to minus 2x. That is equating the powers on left hand side and right hand side. Therefore, x is equal to 1 by 2 and y is equal to, we get y is equal to minus x. Therefore, y is equal to minus half. So x is half and y is minus half, where option given is C. Option C has x is equal to half, y is equal to minus half. Let us mark it. So option C is the correct answer. Next question. If percentage error in measurement of mass and volume of an object are 2% and 3% respectively, then percentage error in the measurement of the density of the object is, we have to find the percentage error. So measurement of mass and volume. So density. So four options are given: 1%, 0.66%, 5%, and 6%. So let us do some small calculation. So error in density, delta rho by rho into 100 equals delta m by m into 100 plus delta v by v into 100. So right hand side is mass over unit volume. So delta m by m into 100 is given as 2% and delta v by v into 100 is given as 3%. Therefore, summing up, it is 5%. 5% is the correct answer. Option C is the correct answer. You please mark it. Next question. Next question. Question number 29. Given that integral of dx over square root of 2ax minus x square equals a to the power of n into sine inverse of x minus a over a, where a is a constant. Using dimensional analysis, the value of n is, four options are given. Option A 1, option B -1, option C 0, and option D none of the above. You have to identify the correct answer and mark it. That is dimensional analysis of n, which is a to the power of n on the given in the right hand side of the given equation. Let us do some calculations. Left hand side, integral of dx by x is capital L over capital L. Dimensions, numerator is L, denominator is L. On the right hand side, we have a to the power of n. Write it as it is. We have to find out the dimensions of a and dimensions of n. Sine inverse of x minus a is dimensionless because dimensions of a trigonometric function is not there. That is dimensionless. Therefore, left hand side is L over L is 1 and right hand side is a to the power of n. So a to the power of n is equal to 1, that is a to the power, so n can only be 0. Therefore a to the power of 0, that is n is 0. It is given option as C. C is the correct answer. Next question, question number 30. In standard equation Sn, that is the distance in the nth round, equals u plus distance traveled in a by 2 into 2n minus 1. What dimension do you view for Snth? So it is nth time, that is 1 over t. It should be t to the power of minus 1 and there is no term of mass and u is the velocity. Therefore, correct answer is option C. That is m to the power of 0, lt to the power of minus 1. That is dimensions of velocity. Next question. Question number 31. Given force is equal to alpha over density plus beta cube. What are the dimensions of alpha and beta? So four options are given. We have to make some analysis. So we will do it. So we know the dimensions of beta cube, that is in the denominator, should be same as density because it is given in the equation. So dimensions of beta cube is equal to dimensions of density. That is beta is equal to cube root of density. Cube root of density, we know is m into L to the power of minus 3. That is Simplifying and removing the square root sign, cube root sign, we get m to the power of 1 by 3 into L to the power of minus 3 by 3, that is L to the power of minus 1. Therefore, force is equal to, it is also given, force is equal to alpha over density, or alpha is equal to force into density. Therefore, that is force is m into L into t to the power of minus 2. Density is, you have to remember, m into L to the power of minus 3. Simplifying, we get m square L to the power of minus 2 and t to the power of minus 2. Therefore, this is given alpha m square L to the minus 2 and t to the power of minus 2 is given here, and m to the power of 1 by 3 and L to the power of minus 1 is given in option C. So option C is the correct answer. Please mark it. Next question. The dimensions of intensity are, so we have to find, four options are given. Option A, L to the power of 0, m t to the power of minus 3, B, L to the power of 1, m square t to the power of minus 2. Option C, L square m t to the power of minus 2. And option D, L square m square t to the power of minus 3. So let us do some calculation. We know that intensity is equal to energy over area into time. You have to remember this. Intensity is equal to energy over area into time. Energy is ml square t to the power of minus 2. Area is L square. Time is t. Therefore, the dimensions of right hand side are m L square t to the power of minus 2 divided by L square t. Simplifying, we get L square and L square get cancelled. M into L to the power of 0 and t to the power of minus 3. This option m L to the power of 0 t to the power of minus 3 is available in option A. Please mark it. Next question. Question number 33. Dimensions of light year is, we know that it is the distance. Light year is a distance. So option C is the correct answer. C, it is given. L is given in option C. Question number 34. The time dependence of physical quantity P is given by P is equal to P naught into exponential of minus alpha t square, where alpha is the constant and t is the time. The constant alpha is, four options are there, dimensionless, has dimension t to the power of minus 2, has dimensions of p, and has dimensions of t square. Therefore, at square, that is exponent of at square, is a constant. Therefore, alpha is equal to 1 by t square, that is t to the power of minus 2. Option B is the correct answer. Please mark it. Next question. Question number 35. Two quantities A and B have different dimensions. Which mathematical operation may be physically meaningful? Option A by B, option B, A plus B, option C, A minus B, option D, A is equal to B. So option A by B is meaningful. Mathematical operation may be meaningful because it is different dimensions. Here addition, subtraction and equality cannot be applied. Only A by B will be meaningful. Question number 36. Which one of the following pair of quantities has same dimensions? A, force and work done. B, momentum and impulse, pressure and force, surface tension and force. You have to remember that momentum and impulse have the same dimensions, ml into t to the power of minus 1. Therefore, you mark option B as the correct answer. Next question, question number 37. A cube has a side length of 1.2 into 10 to the power of minus 2 meters. Calculate its volume. So this is a simple problem. Length of one side is given. We have to calculate its volume. So volume is side into whole cube. So therefore, volume is equal to side into whole cube. Given 1.2 into 10 to the side is 1.2 into 10 to the power of minus 2 meters. Whole cube. So that becomes 1.2 into 1.2 into 1.2. That becomes 1.728 into 10 to the power of minus 2 into 3. That is 10 to the power of minus 6. Simplifying or calculating, we get 1.7 into 10 to the power of minus 6 meter cube. This answer is given in choice A. Therefore, A should be the correct answer. Next question. The equation of state for a real gas is given by P plus A by V square into V minus B equals RT. The dimensions of constant A are, we have to find out, four options are given. First, this is an equation, so I can straight away we have to analyze. This is the PV is the pressure into volume equals RT, temperature. This is the relation. So the first term on the left hand side of the given equation, that is P plus A by V square. Therefore, if for calculating the dimensions of A, the dimensions of P should be is equal to A by V square. That is A is equal to P into V square. That is P pressure is, we should remember, M L to the power of minus 1 into T to the power of minus 2. We know volume is L cube. Therefore, V square is L to the power of 6. Simplifying, we get M as it is L to the power of 5 and T to the power of minus 2. This answer is given in option A. Mark it. Next question. The number of significant figures in 30.00 meters are, options are given 1, 2, 3, 4. That is, here there are 4 digits. All are important because the trailing zeros in a number with a decimal points are significant. The zeros here are meant to convey the precision of measurement and are therefore significant. Therefore, the correct answer is D, that is 4. Next question. Question 40. Which of the following measurement is most precise? Please note A, B, C, D. In A, it is 5 meters. In B, the option is 5 kilometers. In option C is 5 centimeters. And option D is 5.00 millimeter. Millimeter is the smallest and therefore it is the least count. Hence, it is precise. 5 millimeter is the most precise because it has the lowest least count. Please mark the correct answer as D. With this, we come to the end of multiple choice questions. Next lecture or next session will be on previous year questions that are likely to be asked and that were asked in NEET, JEE, KCET and other competitive examinations. So till then, goodbye.